Alright, today guys, I'm working on a Oreck Orbiter floor scrubber. I got this from one of my neighbors. She said she has had it about 10 years, and when she tries to start it up, she hears a buzzing sound like it's starting to go or start up. It spins a little bit, and then she hears a click and it just turns off automatically. My first thought is, that click, I'm thinking that's a thermal breaker kicking in, and it sounds like it's pulling too much current. When I plug it in, this thing dims the lights in my garage, so it's pulling a lot of juice, and this thing's probably got like a little 1/4 horse or maybe 1/5 horsepower motor in it. So let me show you what's going on with it. Alright, so I got it connected. I got a red light here, and it just turns off by itself. I still got the switch on, and it automatically came right back on with the switch still on. So something shorted out on it. We're going to open it up and we'll take a look at it and see what we can find out what's wrong with it. Alright, so I got it flipped upside down on my workbench here. The first thing you got to do is take these 4 Phillips screws out to get this little scrubber pad off. So I'm going to grab my screwdriver. Where this is loose spinning, I usually use that to my advantage. So I break it loose and then spin it clockwise. I think it's screwed loose, break it loose, spin it. So that makes it easier if you don't have like a drill. Break it loose, spin it. And let's do that for this one here. Spin it. Alright, so I should have all 4. Yep, that just comes right off right there. Alright, so now we got the concentric weight right here. Okay, so we got 2 little slots right here, and it looks like it lines up with one of these bolts here, so it looks like you can loosen this bolt to help this concentric stay in place. And I believe that screw head, yeah. So this is this little screw head you see here. Let me zoom in. I'm doing this backwards here. Alright. This little screw head right here is actually the shaft. And what you're going to do is to get this off. Let's see, is this reverse? So you're going to be twisting. Okay, so to loosen this, you're actually going to be tightening it. So when you turn it right, it'll be like a screw going down into something. So this is, I think, normal thread, and I think you screw this to go down. So since this is the actual shaft, go ahead and turn it like you're tightening it. And let me grab a screwdriver here, I'll show you. Okay, it's already loose, but if it wasn't loose, I've taken this apart before, so bear with me a little bit here. I'm gonna grab a socket for this. Alright, I got 9/32. It's probably metric. Let's see if that is metric. That's 7. That's 7 metric. Alright, so if you're working on one of these and yours is really tight and you need something to hold this weight here in place, alright, so loosen this screw. Alright, and like I said, since you're tightening it, or essentially tightening this, you need to turn this like you're tightening it. And if you see right there, this is holding this and keeping it in place right there. Alright. So let's go ahead and screw into it. And you'll see this will actually start lifting up, because obviously the shaft's not going to go anywhere because it's attached to the motor. After a while, I think you got to get to I use a Skinner screwdriver. Alright. So since this one's already loose, I'm going to pull it out of the way and get rid of this plate right here. There's a little lock washer on there, so watch out for it. 2 Phillips screws. Put those here, and we take this plate back, and there is a, it's going to be hard to show, but let me zoom in here. See if you can see in there. Alright, I'm going to have to disconnect this hot wire leading off the main. Actually, I'm going to go ahead and cut the, there's a little zip tie in there holding the wires together. I'm going to go ahead and take that off. That's it. And what you'll see, so you get a white wire coming in, and that goes to the blue wire here, and your blue is going to be your common wire on this motor. You get the black wire coming in, and it's going into the, it's hard to see because I can't get enough slack out of it, but where my finger is, this is a start relay. It's a 3-pin start relay. And then you have green goes to ground, and there's a ground, you know, you can see the lug down there grounded like so. We'll go ahead and disconnect the incoming hot off the relay, and maybe I'll get it where I can turn it and show you. Okay. So this is the start relay. Let me zoom back out for you. And I'll move it up a little bit. Alright. So the hot comes in here, and so it's labeled 4 on this one. There's a 1 next to it, but there's no number 1 pin. Zoom in just a little bit more here. All right. So there's a 1 there, but actually 4's being used right now. So that's the black, or the hot coming into the relay. And then you got a black wire here. This is your main windings, your run windings of your motor. And then you got yellow here, which is the start windings. And so what happens is between pins 4 and pin 3, pin 3 is the run windings and pin 2 is the start windings. Between pins incoming hot and your run windings, there's an inductor coil in here, just like a regular relay. But the way that inductor coil relay is set up is it does not energize enough to move contacts like in a relay unless there's a certain amount of current. And so there's contacts here that move, that brings continuity between the incoming hot to your start windings when there's enough energy to energize that coil. And the only way for that coil to be energized is the inrush current, the big giant surge of current. Like if you have a stalled motor, which, you know, if there's no start windings being energized, you know, you just hear a hum, so that it builds a lot of current because it's not moving, because it's under stall. And so that giant amount of current surging through the inrush current energizes the coil inside here and pulls the contacts, and then brings contact over here to the start windings. Well, once the motor gets going good enough, the inrush current, the overall current level drops down, and then the relay releases the start windings, so then only the run windings are running once the electric motor here gets up to speed. That, I don't believe, is what's going on here, and actually, for a fact, I'll just tell you right now, I know it's not what's going on here. But if you wanted to, you can connect like a little battery between pins 4 and the run windings here, these two, and you can do a quick, you know, continuity test between these two and just tap that battery, and, you know, kind of like just testing a relay. Or better yet, I've already taken this one apart. I'm not going to show it. You can take this apart and look at the contacts, make sure the contacts are making good. You can physically manipulate the contact pad that moves with the relay being energized, and pretty much looking, it's all mechanical. There's no real electrical voodoo going on in this thing. But the way you get this off is there's little plastic secure, I guess you call them rivets. They're kind of like almost like automotive style, where you get the let me get that to focus there. All right, so you knock that center pin out through here, you push it out, and then you can just twist this bracket off the back. If you twist it, it'll allow, there's a threaded rod through the center and it goes through a nut on the back. You can actually separate this apart. All right, so I'm going to go ahead and disconnect this all the way. And my main concern, what I want to look at is, also while you're here, there's two little washers to go between the motor and the concentric, so I'm going to move that out of the way. So what I'm mainly concerned at is I want to measure the resistance of this motor, because like I said, if it's enough to throw this breaker, or there's a thermal breaker in here, is what you're hearing, that click, this thing's pulling too much current. So I believe something's shorted out, there's less resistance in it now, and it's killing that thermal breaker. The fact that it's actually spinning, it's not throwing a breaker because the start windings are not disconnected. The fact that it's spinning showing that this is working. I'm sure there's some situations where I could have the same symptoms and this is not working, but I'm going with my gut feeling on this one and saying this is the actual motor. So you got 3 wires coming off the motor because this is a split phase motor. There's no start capacitor on this one. There's no internal clutch because you have a start relay. And I mean, you can have these split phase motors up to, I think it's like 1/3 horsepower, where you don't actually need a capacitor to start these things. But what you want to do is you want to measure between the common. The common is the one with the bullet on it. Let me zoom in some more so you can see it a little better. Is the one with the bullet, and the run is black, and the yellow is the start windings. And let me grab a little board here and maybe I can draw it out for you. Bear with me now. Alright, so what you're going to have, you get this terminal, we'll call this common, and then you got, these are just windings, and we'll go with R for run. I'm writing upside down, so this is going to be fun. And then you got more windings over here, and this is going to be your start. Okay, yeah, that's right. And so what you want to do is you want to measure resistance between your run winding lead and your common, and you want to measure resistance between your start and your common, and then you also want to measure between these two, start and run. So what you're going to have, let's see, am I in view up here? Well, I can see that one. Okay. Alright, so the first one we're going to do is we'll say run, and I'll just put a dot, common equals, and then we'll do start common, and then we'll do run and start. Let's see if I remember correctly. Your start windings are going to always show a higher resistance, or start to common is going to show a higher resistance than run to common, and then these two combined should equal the same resistance as your run to start. Because if you look here, if you're eliminating this and you measure, just pretend this is one big giant wire. So let's measure this and see what we get. Alright, so I got some cheap little multimeter here, clamp meter, and I'll get this where you can see this in view here. Alright, I think you can see that. Alright, so the first one I'm going to do is run in common. So I got black lead on the blue here, that's your common, and run, which should be the black here, and I get auto ranging 0.5 ohms, and that is extremely low. Alright, so 0.5. I got my board down here, I'll write that down. 0.5. Alright, now we got to do start common. And so again, keep your lead on the common wire, and we'll go to the yellow wire for start. And we get 5.2 ohms. Okay, which that sounds, I think that sounds about right for start windings. Again, like it'll be more greater than your run windings. I got awful handwriting, so when you show this, it's going to be bad. All right, so now we got 5.2 and we got 0.5. If there's nothing wrong with it, like I said, the run or the start windings are already showing better or greater than the run windings, so that's already good, even though the run windings are extremely low. If there's nothing wrong with this, the combination of both of those, we got 0.5 and 5.2, we should see 5.7 resistance across the run and start terminals. So one to yellow here. Okay, you can still see. So I got 4.8. That's less than what the total is. So we have a short. Based off that, we get a short between the windings. So let me write that down. Alright. Just as a sanity check, I'm going to check each terminal against ground and see if there's a resistance. So I'm going to do the start windings. Alright, so we get like 1.4 mega ohms. That's good. Let me do the common. 1.2 mega ohms. And let me do the run windings. And we got 1.5 mega ohms. So there's no short to the actual chassis of the motor here. So we have an actual internal internal short in the motor. And let me draw out what I believe is happening and see if it makes sense. Alright, so here's what I think is going on. So instead of the drawing where R goes directly to C and C does directly to S, there is some sort of short in between the two windings. So even though you got two wires, you know, here that's pinched together, it acts like one single wire. And so you can, based off the numbers that I received, I can actually kind of test this. So if I label this, the shorted area is R1, between R to the point of the short is R2, and from start winding terminal to the point of the short, R3. And I'm going to get a lot of math on you here. There's a little bit of algebra here. So here's some high school algebra here for you. So if you recall, or okay, let's just say if I took a measure from R to common, then what it's going to be is resistance R2 plus R1. And we already know, because we measured it, is 0.5. And if you take the resistance from the start terminal to C, it's going to be R3 plus R1. We got there, and we know that equal to be 5.2 ohms because that's what we measured. And if you do from the run R to S over here, you'd be doing R2 to R3. And again, because we measured, we got 4.8. And then you can mess around with the equations and everything, and this is what you can come up with. R1 is essentially 0.45 ohms, and R2 over here is 0.05 ohms, and R3 over here is 4.75 ohms. So this confirms, because all these equations add up and everything works out right, you don't have to do any of this. I'm just kind of throwing a little bit extra in there for you. Yeah, we definitely got a short in between the things. Like I said, because R to S, you know, it should be down to here, because these two values don't add up to this plus this, then we know we got a short. But anyway, there's the math. There's kind of a visual for you of what the hell's going on here. And so pretty much this thing needs a motor. I've already ordered one. The lady said that you know, these things brand new are like $300 for a whole new unit, and there's really nothing to it. Like, actually, the motor came with a diagram. I'll show you just schematics of what the hell is, you know, in this thing. Alright, so pretty much you got your 3 wires coming in, and you got your metal housing. It's grounded out, so that's done. You got your switch that's on the very end, and it just has a wire from the neutral to the light to light it up. Nothing there big. Harness comes around, goes to your relay. Your relay, you know, you've seen that, and then you got your motor. So really, the most expensive thing on this thing is the motor, and it's $115. I bought it from Central Vacuum. Was actually the cheapest place. I'm sorry, let me look it up here. CentralVacuumStores.com. Yeah, that's a plug for you guys, so I'm throwing it out there. I looked all over for the part number for this. I'll put a part number in the description. The actual part number that I had to order for this particular one. And this one is the 600 model number. The actual unit itself is a 600, where's the model number? ORB 600MW is the model number. Well, like I said, a new one it's $300, and pretty much if you replace the motor, you're pretty much getting a brand new unit. Yeah, there's a bearing on that cam, eccentric weight, whatever you want to call it. It's fine. It's sealed. It's still good. But yeah, you replace the motor, pretty much you've refurbished it into a brand new unit. I mean, anything else on here is $10 or less to fix, if not free. So if she gets another 10 years out of it, I'd say it's worth it. She said go ahead and do it. $115, pretty much refresh $100 or $300 new unit. So while I got this board out here, I think what I'll do is set up. Alright, I got the new unit. Let's take some measurements off the new unit here. So, move this out of the way here. And as we're doing this, I will write down. Alright, here we go. We got this here. I'll write down the old, or I'll write down the new measurements. So we can compare to see what an old versus good is. I'm just going to put that. Hopefully you guys can see that. Let me help you focus here. Alright, so you got it on resistance here. So we're going to measure common on this one now. It's white. So we'll do white to the black run over here. Okay, let me get a better grip here on this. Alright, so run to common. I got 2.4. Alright. Alright, right, let's do start to common. 2.4, remember that. Start to common 5.1 or 5.0. We'll say 5.0. And that's a good thing because, again, like I said, you know, your start windings are always going to have higher resistance than your run windings. And so now, since we get 2.4 and 5, we should have 7.4 between the R terminal and the S terminal here. Let's see what we get. So yeah, 7.4, perfect, dead on. That's what you need to see. All right, so we'll compare our numbers here. All right, there we go. So originally we had 0.5 resistance for the run to common. Now we got 2.4. That looks a whole lot better because if you think about 0.5 ohms devoted into 120 volts, you're looking at like a start current of 240 amps is what that's trying to pull, and that's why your breaker throws so quickly on this. Start to common or S to C 5.2 originally. We got 5.0, and the total combined is 4.8, and we got 7.4 again. These two numbers should add up to this number, and these two did not add up to this number, and that's why we believe we had to short. All right, so let's swap this motor out and make sure, you know, that everything we did here is right. So let me bring the unit back up here, and we'll get back to that. All right, get the whole assembly back up here. Grab your 7mm wrench, and we're going to take the other 3 bolts out because that's what's securing this motor to the frame. Half turn, breaks it loose. Maybe a little bit more than half turn. And remember, each one of these has like a lock, that little lock washer on there, so watch out for those. By the way, I'm going to start labeling some of these videos as what I call anti-throwaway society. That's where pretty much majority of people would probably take something and throw it in the trash. My last video where I replaced the seal on my Cobalt air compressor, that was one where the whole unit of the air compressor inside, you had to buy the whole unit. They wanted $200, and I was like, no way. Ended up fixing it for $7. So this is the kind of stuff for the guys that, you know, wait a minute, I know how to fix something. I'm not going to throw this away because I can fix it cheaper than I can buy a new one. And so that's what this is for. And like I said, I'm going to start calling these anti-throwaway society because nowadays that's all we are now, is a throwaway society. Everything's made to be thrown away, and that sucks. All right. What you'll notice on these motors, I have a marker here. Let's see if I got a paint marker here, because I'd hate to. All right, I remember the original had a blue. Me talking and stuff, I could see myself putting the wrong motor back in, but isn't that coming in? Okay. All right, so we're going to take this out. Make note of how the wire exit point. There's a little grommet here, and if you're standing, if you put this in here and line it up, you will see that that grommet where those wires exit, it's right up against where they exit here. So that's how you line that up. And it appears that the new motor comes with new bolts. If they're the same size, we'll see. Might grab some new bolts here. Not the best tool, but I'll grab it. Tell you what, I'm gonna tear all these bolts out now. Come back. Alright, I got the bolts out. One thing I want to talk about is anytime I get any kind of new part, it doesn't matter what it is, automotive or whatnot, if there's any kind of marking, part number or anything on it, I kind of want to just double check it, compare. This motor appears to have some kind of model number. This is Chiafua Components. You'll see it has a, man, I hate working backwards. So I got an IC45L0001. This is the new one here. Pop that in there. And if you compare the old one, you get, if you focus, same thing, IC45L0001. I've tried looking up this manufacturer. I found a data sheet for these things, but I don't think there's any. I tried to see a way if there's, you can buy this directly. Maybe Alibaba or something has one of these, because it's not exactly a specific motor. It's kind of semi-universal. Obviously, I'm sure they put this in, you know, other kind of applications and stuff, but without doing all the research or whatever, you know, I try to save the lady some money, but I couldn't find anything else that this, you know, potentially goes in. I think I even tried looking up different vacuum cleaners, because I figured if Oreck picks this motor for this, maybe they picked it for a vacuum cleaner or something. Anyway, yeah, couldn't find it. So anyway, I took the bolts out that it came with. I'm gonna put those new ones in. And just look down here to line up the holes. And I'm not going to put this one back in because that's what holds the eccentric in place when you tighten it. Let me get one in there started. Hey, right there, I got that one started. Holy crap, I actually got that thing lined up. I'll tighten these down. This is some kind of, you know, this is like a cast aluminum piece, so don't tighten the ever-loving crap out of it. You'll strip the holes out, and that wouldn't be good. Alright, let's just say you forgot what the hell's connected to what. You know, you got 3 wires over here, you got 2 here, and you got the relay. Well, if you need help, you can always reference this diagram again here, and we'll just go ahead and do that. So we know that the black wire, that black wire is short, so I'm not going to mess with it. The white comes in and connects to the, well, it's only got a bullet on it. So bullet to bullet, and the white goes here. Make sure that's pushed in there nice and snug. And then you got your start windings, your black, and your incoming hot. So I know that comes on the relay. So yellow goes on pin 2, according to the diagram. So we'll go ahead and do that. Black off the motor goes to pin 3. And black coming in goes to pin 4. And you don't just have to have this down here when you room to work with this wire. There we go. Alright. I'm putting it together just to test. I'm not going to put a zip tie on it. Yeah, actually I am. I can find it. Nope, that's my meter going off. Alright, get it together. Put the plate down in place, line up holes, and remember the 2 Phillips go here. Tell you what, go ahead and take that bolt. Just to keep it lined up. Tighten it down. Tighten that one down. Take that bolt. Lift this bolt up, or take it out. And remember, this, you have to thread the shaft. You have to turn the shaft counterclockwise to tighten this on. As you tighten it, you'll see it start coming down, or the plate starts moving down. All right, now make our work a little easier. Put that there. Slam that up against there. Man, I'm glad they did this. And again, keep going counterclockwise. Camera. There's there. But you know what? I forgot to do something here. Alright. Always forget to do something when I'm doing something on camera. I'm starting to notice that this shaft's sticking out a little bit too far. I forgot to put those washers on. So, now I get tiny to release it. Alright, remember there was 2 washers that went right there, and I said, hey, don't forget it, and then I forgot it. Yeah, those washers. Those are the ones that you need to put on here, because otherwise it'll be too tight down on it. Alright. Counterclockwise to put it back on. Yep. See, if that shaft is proud of the eccentric here, then it's you don't have all the washers on it. Yeah. Alright, now I can tighten this down. And before we put that little disc pad, whatever you want to call it, on, I think we're going to plug it in and test it. One, two, three. God. Ooh, boy, that thing's got some. She vibrates. Alright. I wasn't used to that because I guess when this thing started up it would just barely do that, so it wasn't fast enough to even get some movement there. But it's working. I didn't hear any crazy hum, so that motor definitely was the issue. Let's see if I can get this put on right, and I'll show you guys what it looks like standing up instead of vibrating here on my workbench. Where my damn Phillip? Yep, just like the trick here, we're doing it counterclockwise, tighten it. Counterclockwise, tighten it. Alright, if you guys got this vacuum cleaner, if you like me fixing stuff, I try to look on YouTube to find out if there's anybody else fixing the same thing. Obviously there's like 20 other videos out there of somebody fixing it. I'm not gonna make a video on it. That's just it's you know, it's a waste of my time unless I see a lot of information that they're leaving out. If they do it really quick and don't leave enough information, you know, you guys are curious, want to know some more stuff about it, I may do a video then. If you like this kind of stuff, I try to building different things, repairing stuff. If you would just subscribe to my channel. Now that YouTube has that stupid rule where you have to have 1,000 subscribers, I got tons of views from different videos, but there's not really a theme. I guess you could say fixing stuff is a thing. I got the views, I just don't have the subscribers. So if you would, if this helped you out, please subscribe to my channel. It would really help me out. You know, I'm only pulling in a few bucks a month, but I just usually let that account just keep building money. I haven't even taken any money out yet. But if you like this, again, subscribe to my channel. Next scene will be me starting this up in the upright position. So hold on one second, you'll see that. Alright, let's try this out here. Hopefully this won't, we'll lift it up a little bit. See how she works. Sounds pretty good. Well, still buying a new $300 one. This lady has had this one fixed for 115 bucks. So, yeah, maybe this will last another 10 years. She'll get her money's worth. Alright guys, if you have this same model or if you have another model, I think this fits pretty much the same series. If you have an Orbiter 550, 600, or 700, it's probably pretty much the same. There may be a variation in the actual motor. But let me know if you got this one. I've looked all over. I can't find another video of somebody working on one of these. Hopefully this helps you out. If it did help you out, please subscribe, thumbs up, all that, yada, yada, yada. Leave a comment. You know the drill. Thanks, guys.